Hey there, STEM enthusiasts. I'm Courtney, and welcome back to the STEM Spark, where we ignite creativity, curiosity, and confidence in every learner through science, technology, the arts, engineering, and math. Okay, if you have ever wanted to bring a little STEM into your home, then this episode is for you. You don't need any fancy labs or expensive supplies. We are going to do I'm going to share with you some of my favorite easy STEM experiments that you can do right in your kitchen with materials you probably already have or are very easy and inexpensive to get. So let's jump in. Today, this episode is for parents, grandparents, aunts, uncles, caregivers, tutors, anyone who get the joy of caring for little ones or trying to keep kids entertained while learning at home. So, I am going to share some of my favorite experiments with you. These are easy. There's no fancy lab coat required, unless you, of course, want one, which is always fun. I will say, in my experience, anytime you break out the safety glasses, it feels like a level up for students. So if you have some safety glasses lying around, break them out and kids start to feel a little more scientific or like a scientist. So let's jump in. Okay, let's first start with why do we want to do STEM at home? Um, it's it's really powerful to do at home experiments with your kids and with kids that you know. I think first it makes the experience less like schoolwork and more like an adventure or a fun experience, right? Second, kids and honestly adults remember hands on experiences way more than reading something in a book or watching a video. Third, and a wonderful component to STEM at home, it encourages curiosity. When you're not worried about grades or rubric or what your neighbor is going to say about you because of your answer or how you do it, you get to really explore those questions and curiosities in your mind. And last, but certainly not least, I believe that anytime kids get to learn with other adults that they have a relationship with, that they do life with on a regular basis, it helps them realize that STEM can be for everyone. It's not just an at-school thing. This is a life thing. And I think it makes it more accessible for kids of different abilities and different strengths and different ways of looking at things, right? And so I think it just opens up some more doors for possibilities. So that's why I really love encouraging STEM at home. All right, we are going to talk about one of my tried and true experiments. This is a fun science experiment that you can do. It does involve science. It talks a lot about like observation skills, or you practice observation skills. And it is called Dancing Raisins. It is a tried and true experiment. And it's been around for a long time. So it's super simple. You just need a clear cup or glass. I will say if you have an actual glass, like a mason jar or something similar, that works the best in my opinion. But even if it's plastic, as long as it's clear, you need to be able to see through it. You need either soda water or lemon lime soda. So again, the soda that you use, it does have to be soda. It needs the bubbles, and then it needs to be clear. And then you just need a handful of raisins. If you don't have raisins, craisins, or something like that would suffice. All right, so what do? You take your glass, you fill it with your soda water, and then you put a few raisins in. I would not do an abundance of raisins to start. You can like refresh and do more raisins later, but I would do maybe 5 or 6 to start, and you just drop them in and they'll sink to the bottom and then they start to float back up. And then you keep watching and they'll start dancing and they will keep dancing for several minutes. So it is super fun, super cool, and most kids really enjoy this one. So, what is the real magic? The real magic is always in the questions. What did you notice? Simple, low pressure. There's not really a wrong answer unless they're like talking about the dog, you know? So, really low pressure, kind of just make an observation. What do you see? What made the raisins dance, right? So, having them think about, okay, why is this called dancing raisins? What is causing the raisins to dance? What does the dance look like, right? And so having them start to think in that critical way. All right, what is the spark? The spark is the bubbles from the soda cling to the raisins and it makes them float to the surface. When the bubbles pop at the surface, the raisin sinks again and then it attracts more bubbles and does it all over. So this is a fun way to introduce buoyancy. You can talk about states of matter with gas and liquid and solid, and about gas coming to the surface, popping, gravity, all of those types of things. So there's lots of different areas that you can connect. I do like this too because you can do it with older kids and younger kids and just kind of adapt your questioning to fit the needs and the related science to that level. I would say that this experiment is really great for younger learners because it's super fun. It's simple. Like, I would let my first graders do this from start to finish, with facilitation and not necessarily me pouring it. I would probably let them do some of that, especially if I had like cups pre-measured or something like that. And then they get that ownership of doing the experiment from start to finish. And then it's really low key. You can incorporate the science chat with it, but it's really about observing and making those observations and then thinking about, okay, here's the observation. What did we learn from that? Or what can we discover from that? And different things like that. And then pushing in some vocabulary, right? Like gas, liquid, buoyancy, gravity, those types of words, throwing around and helping them kind of understand and relate those in. So this is great. I would do this kindergarten through probably third grade. You could definitely do it higher, but I would probably keep this K3 for my purposes. But you do it with whatever students that you have that you feel like would get something out of it. It is just fun too, right? All right. So the next experiment we're going to talk about is called the paper towel art merge. So the science on this is capillary action, and then we're going to incorporate some fun art. So what you'll need is paper towels, washable markers, don't use the Sharpies, and then 2 small cups of water. They do not have to be clear cups, but you do kind of want like a shorter cup. So if you have almost like a measuring cup or a medicine cup or something with fewer ounces, would be great. If you don't have shorter cups, then you'll just need more paper towel. So not a problem. All right, how do you do it? So you take your paper towel out, and it is best to use white paper towels. And then you have your kiddos draw a design on the paper towel, but they want to leave some white space. So I would say just making sure that um, I would I would probably say about 50% is still white and then 50% is colored. You can obviously go a little bit either way, or maybe do multiple iterations of the project and have some designs have more white space and some have less. But to start, I would say 50% is a good place to start because then they get to see the real magic, right? So draw a design, leave some white space, fold it so the design is hidden, or like roll it up a little bit so that you can kind of fold the paper towel. And then you're going to place the edges. So you're going to roll it up, and then you're going to place the edges into the 2 cups of water. So after you draw the design on the paper towel, roll it up. One edge goes in this cup, one edge goes in this cup. And then you watch as the colors magically appear and spread, right? So what's the real magic? Let's ask a few questions. What do you think will happen when we put the paper towel in the water? What's going to happen? So you could talk about this while they're doing their design. You could talk about this as you're setting up the cups. Or like right when you first put it in, you could even talk about this a little bit. But I would get them to make this hypothesis before the water starts to really move, because then they're going to start observing and seeing what's happening. So think about that question prior to like really seeing the action. And then another question while the water is moving could be, what caused the water to move? These little conversations are low-key ways to really emphasize that learning component. So asking these questions and having students think about these things is a great way for low pressure, just observational kind of hypothesis style thinking that really helps solidify their understanding, what they're observing, what they're doing. They're making those connections to other things. So they're going to think about the time where they had to wipe up a spill and the paper towel absorbed the water, or when they drew a symmetrical design in art class, or whatever it is, right? And so having those conversations and pulling in those questions is just a great way to kind of extend that learning past just the obvious, right? Okay, what is the spark? The spark is capillary action. It is a great introduction to this, how water moves through those tiny spaces. It also lets kids be creative with their designs. You could maybe do a symmetrical design, or you could have them do something different in the 4 different quadrants of the paper towel. Like whatever you're learning about or whatever you want to emphasize, pull that into the experience, right? And so it just helps, again, make those connections and take a little bit of the pressure off that I think a lot of students feel at school. Okay, so that's a super fun, super easy. You can do that with stuff you already have, right? All right, the next experiment that I want to share with you is called marshmallow towers. And if you don't have many marshmallows, that's what you'll need to get, and toothpicks. This emphasizes engineering because they're going to be designing a structure and building, and it also has some math components. So let's see what we do. So how do you do it? You have your mini marshmallows and your toothpicks. Obviously, they're going to put them together, and they're just going to be challenged to build a tall tower, using just the marshmallows and the toothpicks. Now, I will tell you from experience, don't let them pull the marshmallows apart. It's not worth it. Um, I did a similar experience with my kids at school, and they started pulling the marshmallows apart, and it was utter mess. And so if you like mess, let them do it. If you don't, like, I was getting sticky marshmallow off my tables for weeks, guys. So maybe not. I probably wouldn't let them do it again. But at home, it is a different environment. So maybe that's okay. But they're going to just connect them together and build a tall tower. Encourage them to try different shapes. Obviously not circles, squares, triangles. Can you even do a pentagon or different things like that? And so we're pulling in those geometry concepts. I will tell you this tip: triangles are surprisingly strong. So I wouldn't give that away at the beginning, but maybe giving them a little tip or trick throughout their process, especially if you see that they're struggling a bit, could be good. So once it topples, talk about what worked, what didn't work. maybe have them try again, measuring to see how tall each tower got, maybe having them even draw out a plan, or say triangles were this tall, squares were this tall. If I did it in the shape of an Eiffel Tower, it was this tall. Like whatever you're doing, pulling in those math concepts as well with measuring and height. You can even weigh it. Like, how cool would that be? That sounds fun. So the real magic is in the questions. What gave your tower the most stability? So with some students, that word stability, you may need to talk about and kind of define. Some students are going to understand right away what that means and how to describe that. And then another question you could ask is, what made the most difference in your design? I love questions like this because it gets kids to not only think critically, but reflecting on, okay, well, when I did the triangle, this is what happened. When I did the square, this is what happened. When it was super big, this is what happened. When it was tiny, this is what happened. So having them kind of reflect on that and think about the cause and effect, or how different shapes related to different things, is a great way to really have them deepen that understanding and that learning. All right, the Spark, kids get a hands-on lesson in structural engineering. They involve some problem solving and some geometry. Plus, there's a built-in snack. I didn't let my students eat them because they were all touching them, but at home, it's a different story. So build your tower and then snack on your marshmallows. Sounds like a fun day to me. All right, so that's what I have for you. I will link like an adult explanation sheet or a guide sheet below. You can click on that. It's going to give you the materials, the instructions, and some questions that you can ask for each of the 3 experiments we talked about today. All right, super easy, 3 experiments, low cost STEM experiments you can try today. The best part about these activities is that they're quick to set up, they spark big curiosity, and they can be scaled up or down depending on your child's age. You don't have to have a science degree to do these STEM projects at home. You just have to be willing to explore, make a little bit of a mess, and ask questions together. So this week, pick one of those experiments, try it with your kids. Take pictures, share your discoveries, and remember, STEM is all around us every day. Comment below what experiment you and the kids are going to do first. I've got a document, again, linked below with directions for the experiment, questions you can discuss, and a little bit of science info is included in that. So if you want a little background science refresher, that's in the document as well. All right, until next time, don't forget, follow the show, like this video, leave a review, share it with a fellow educator, parent, or STEM enthusiast. This is Courtney, and you've been watching the STEM Spark, where curiosity sparks creativity. Bye.